So we've discussed in the previous playlist what the difference in potential is, how to calculate it, and we've discussed in the past two videos what the concept of work is. So now we want to try to explain what the relationship between the two are. So here we have a charge distribution. It could consist of a volume charge distribution, a surface, point charges, line charges, whatever you have. And then these are just 2 points in space, empty points in space. Now we know from before that there's a potential difference between these 2 points in space. But now, what if you make a path, choose any path, and take a charge q, you introduce the charge q to this region, you move the charge q from point A to point B along this path, and as of course you move the charge q, there's going to be a force on this charge q because of the electric field created by all these charges. So what is the work done by the electric force when you go from point A to point B along this path? Now we know, we saw the concept of work, and we showed that the work to go from A to B is integration from A to B F dot dr. Well, what is the force? What is the electric force on this charge q as it's moving from point A to point B? The force is just the charge times the electric field. I can take the electric field, the charge outside, and then what's left over here? Can you identify what's left over here from the part we did on potential? We already did this in detail. This is nothing but the difference in potential between points A and B. That means that the work to go from A to B, the work done by the electric force as the charge goes from A to B, is nothing but the charge times the potential difference between points A and B. Now we could define then difference in potential between 2 different points in space to be the work per unit charge. This is one way we could define potential difference, and in many cases, and this is the way it's defined to begin with. The reason why I didn't want to define it this way from the beginning is because I wanted to stress the fact that there is a potential difference between 2 points in space, and you don't need to have a charge here to go from point A to point B in order for there to be a potential difference between points A and B. The potential difference between points A and B exists because of the electric field that's created by this charge distribution. So you don't really need to have a charge here and move it from A to B and get the work and divide by the charge for a potential difference to exist. So for instance, let's remember this example where we calculated the potential difference between point A and B for an arbitrary path, and we found actually that it's independent of the path. For a constant electric field region, we found the potential difference VA minus VB is just electric field times this distance, the distance along the electric field. If you want to then imagine that you bring a charge q now to this region and you move the charge q from A to B along some particular path, and you want to get the work done by the electric force as the charge goes from A to B, well, we showed that the work is just q times the potential difference. So it's q times E times D. In this example, we already did this example in detail before. We showed that the potential difference between point A and point B in the presence of charge q1 is just equal to kq1 over Ra, the distance between the charge q1 and point A, minus the keq1 over Rb, the distance between the charge and point B. You can imagine if you introduce a second charge, q2, and you move this charge along some path between points A and B, how would you get the work done by the electric force as the charge goes from A to B? Well, it's just the charge times the potential difference.